Around 150 refuse lorries bring in municipal waste from Prague and surroundings to ZEVO every day. Each truck, with a load of up to 7 tons, passes through a radiation control right at the entrance. The waste may contain weak sources of radiation, such as discarded military compasses or old laboratory equipment. This waste is taken to the storage facility for radioactive waste. This is followed by a double visual examination of the waste being brought, weighing and registration. Only then is it possible to unload the remaining waste in the area of the reception gates, where it's possible to cut large pieces with Lindemann scissors, or according to customers' requirements, crush the waste in a jaw crusher. Malešice is home to one of the most modern facilities for the disposal of municipal solid waste in Europe. More specifically, a facility for energy waste recovery, simply ZEVO. This ingenious plant is able to realize the energy potential of waste by burning it to produce electricity and heat and supplying it to Prague's households. The calorific value of the waste is comparable to brown coal. Unlike non-renewable resources, there is always enough waste. The volume of waste is reduced to the 10th by incineration, whilst also using other products that occur during combustion. Thermal treatment of waste replaces wasteful and environmentally unfriendly waste disposal in landfills. The following virtual tour will allow you to visit individual ZEVO plants and become familiar with the details of this modern technology. This waste container, with a volume of 11,000 square meters, serves as a temporary repository for waste before it's put into the boiler. The bunker capacity allows for the storage of the weekly waste production of the city of Prague. All the air is sucked directly out of the bunker into the boilers to reduce the waste stinking the surrounding areas. Crane operators mix the waste due to its disparate composition and then stoke it up into the boiler using 2 polypus cranes with a capacity of 5 tons. The average weight per batch is around 2.5 tons of waste. The stoked up amount of waste is recorded and registered for statistical purposes. Receipt of the waste as well as the operation is continuous and stops only once a year during a 10-day shutdown. Here, all the slag which is formed as solid parts after the waste incineration is collected. Approximately 250 kilograms of slag is created from 1 ton of waste. The slag is regularly tested to determine whether it contains toxic substances which would make it dangerous for human health or the environment. Thanks to testing, we know that our slag has been non-toxic for nearly 20 years and therefore suitable as building material in roadworks. Metal scraps accounting for about 4% of the weight of the slag are electromagnetically separated from the slag. Metal scraps are then recycled. Waste is burned on a grate with 6 cylinders which are lined with nearly 4,000 fire grate bars made of thermally resistant nickel-chromium steel. Waste is stoked up to the cylinder by means of a feeding table, and there it's burned at a temperature of about 1,200 degrees Celsius. To ensure high efficiency and correct stoichiometry of combustion, there is a surplus of air in the boiler, which is blown into the boiler by the slits between the rolls and the secondary air from the boiler walls. This way, one boiler thermally uses between 12 to 15 tons of waste per hour. Ignition of waste is carried out by gas burners, which then go out. The fact that the waste burns by itself is a basic condition for the energy recovery of waste. The incinerated waste turns into slag, which falls through the grate into the Martin wet slag discharger, which is completely flooded with water in order to help to keep the vacuum environment in the boiler. The slag falling into the Martin discharger also cools, splits into smaller grains, and does not stir up dust in the surroundings. The boiler is designed as a vertical 32-meter high boiler with 3 drafts and membrane walls. The purpose of the boiler is to use the thermal energy produced by burning the waste to heat water to produce steam. Water and steam are distributed by boiler tubes. Through the heat exchange surfaces of the tubes, water is heated and turns into steam, with parameters of a temperature of 235 degrees Celsius and a pressure of 1.37 MPa. In the third boiler draft, an air heater, steam superheater and economizer are situated in the direction of the flue gas flow. One boiler thus produces on average 35 to 40 tons of steam per hour. The spray dryer is the first functional unit of the flue gas cleaning system, which serves to remove the largest dust particles. The principle of separation uses the centrifugal force of the flue gas, which spins inside the dryer. Heavy dust particles are ejected to the walls, on which they slip into the waste ash silo. The second function of the dryer is to dry the lime suspensions drawn out from the wet exhaust gas cleaning stage. The slurry is countercurrently sprayed by a high-speed jet to the volume of the dryer, where hot flue gas from the boiler evaporates water proportion so that the product of the dry ash is left. Spraying against the flow of the exhaust gas also increases the efficiency of the entire process. The electric separator is the gas cleaning system main functional unit which removes dust particles. The cleaning efficiency exceeds 99.99%, which practically means that it reduces the amount of dust emitted into the air from grams to milligrams. In the body of the electric separator, there are 3 horizontal sections working on electrostatic principles. Electrical discharges charge dust particles passing through the individual sections, and the particles are subsequently deposited on the sedimentation electrodes. The dust particles are then cyclically shaken off the electrodes section after section. This ensures continuous operation of dust cleaning. Dust particles captured by the electric separator are removed along with the fly ash from the spray dryers as solid residues from waste gases. Wet lime scrubbing is functionally the most difficult part of the entire flue gas cleaning system. It's a system of 2 rubberized scrubbers with successive sedimentation tanks and neutralization. The primary purpose of this system is to remove the acidic components of flue gases, like hydrogen chloride and sulfur oxides, by injecting slaked lime, which has the ability to react with these gases and not to release them into the atmosphere. Practically, jets are introduced in the middle diameters of the scrubbers in order to continually spray the slurry of slaked lime, which drives the desired chemical reaction. The chemical environment of the first scrubber, moreover, allows the removal of heavy metals, including mercury. It's the highly acidic environment of pH 1, thanks to which all metals are dissolved and thus cannot get into the air. This system is so sophisticated that ZEVO Malesice is continuously below 90% of permitted emission limits. All the substances separated from the 2 washing machines are finally fed into a final neutralization tank, where they are converted to a non-toxic form and then discharged into the spray dryer. Water is evaporated from them and a relatively small amount of ash is left there. In addition, there is a scrubbing lime slurry enriched with 10% active carbon. It captures not only the gaseous forms of mercury, but also organic pollutants such as dioxins and polycyclic aromatic hydrocarbons of the type of chlorinated benzenes. The catalyst is used to remove dioxins and nitrogen oxides by selective catalytic reduction. It's the worldwide technological leader in flue gas cleaning processes. Simply speaking, nothing better exists. In the stainless steel casing, there are 4 floors of titanium ceramic blocks with the catalytic component of vanadium oxide and tungsten. Individual floors have a honeycomb structure. Flue gas passes through them, and dioxins, furans and nitrogen oxides contained in them are catalytically decomposed. To ensure the effectivity of the reaction to remove nitrogen oxides, a catalyst reducing agent of ammonia water must be injected, while the gas burners increase the temperature to secure the proper chemical reaction. The resulting heat is then captured and reused in regenerative heat exchangers. Regenerative heat exchanger. Excess energy from the catalyst is used to reheat water for the hot water pipeline and for heating of flue gases before entering the chimney. This way it prevents condensation of water vapor before discharging the flue gases into the air. With its height of 177.5 meters, it makes the ideal location for a radio transmitter. The chimney is, thanks to the parameters of new flue gases, oversized in width and height. Its outer body is now replaced by a 7 times narrower chimney, which is hidden in an outdoor concrete shell. This is a hidden chimney made of stainless steel, lined with a ceramic sleeve. Continuous measurement at an elevation of 24 meters. All authorized measurements for the control of potentially produced emissions are also carried out here. The energy contained in the steam is converted to electrical energy by means of a generator and the mechanical work of the turbine blades. The turbo generator is a downstream one with unregulated offtake and varying rotational speeds of the turbine and generator. The maximum output of the generator is 17.5 megawatts. The hot water pipeline. The unregulated offtake of the turbo generator is designed for taking up to 60 tons of steam per hour, which will transmit to the base exchanger the heat of 130 gigajoules. It's distributed to the power grid for public consumption by means of hot water pipelines. Condenser. The function of the condenser is to cool the steam coming from the turbo generator to condensate. The condensate is then distributed through piping to the boiler and reused to produce steam. The entire ZEVO steam system can be considered cyclical apart from minor losses. Cooling is provided by forced air circulation by means of 6 high-capacity fans. The number of fans depends on the operating temperature of the outside air and the amount of steam running through the turbine.